Hello, everyone, and welcome to Passive House Accelerator Live, where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. I'm Zach Semke, director of the Accelerator, and we are excited to have Anna Leopold and Grayson Jordan from Paul Castrucci Architects join us today for Next Up. Our host of today's Next Up episode is Carmel Pratt of Bright Power. With that, Carmel, please take it away.
Thanks so much, Zach. And thanks so much to Anna and Grayson for joining us today for what is going to be a wealth of knowledge. It's equal parts research study, case study, as well as some really important highlights on how to make good decisions on our projects. So I hope with that we leave plenty of time for questions at the end. I'm going to do a quick intro to Anna and Grayson, and then I'll let them take it away into the presentation, which is going to be speaking about a NYSERDA Buildings of Excellence Early Design Support Research Project, where they looked at several electrification measures, and that research is available in a report, and there'll be a lot of juicy content to take away from the presentation as well as from other links. So Anna is joining us as an assistant project manager and energy analyst from Paul Castrucci Architects, where she focuses on sustainable climate resilient design for affordable housing and community driven projects. Her work includes flood resilience efforts like the Baruch project's retrofit after Hurricane Sandy, as well as energy reduction strategies for NYCHA campuses. Anna holds a master's in architecture and a BS in architecture from Northeastern University. And Grayson, also from Paul Castrucci Architects, is a certified passive house consultant and registered architect with extensive experience in energy efficiency and sustainability across New York, New Jersey, and Massachusetts. He has led high-impact projects like the R951 residence, New York City's first passive house net zero building, and the award-winning Bethany Senior Terraces in Brooklyn. Grayson is also an advocate for social equity and design through his work with AIA COPE, the Social Equity Committee, and the NYC Energy Code Advisory Board. Anna and Grayson, thanks so much for joining us. Take it away.
Thanks for the introduction. Really pleased to be here today talking about pathways to affordable electrification, passive house, geothermal, and beyond. This is a presentation of our NYSERDA Buildings of Excellence Early Design Support Research, with the case study being the Beacon Project. Just before we get started, a couple of quick words about this NYSERDA program, the Buildings of Excellence program. Buildings of Excellence is run by NYSERDA. It's the BOE umbrella offers two pathways for RFP opportunities. First is demonstration projects, which supports project-specific hard cost initiatives that demonstrate scalable and replicable technologies and strategies to create clean, resilient, and carbon neutral multifamily buildings. And then the other side of that is the early design support, which we are presenting here today, which that program supports soft costs and really earlier in design phase research and looking into strategies that can be brought into the project at the early onset. This case study actually has both a demonstration project and an early design support aspect to it. But here we're presenting the research from that early design support project. For that early design support, I should say the way to get involved with that is to first apply at NYSERDA to become a design partner, and then you can put in an application for a project specific or research specific grant. If you don't mind putting a link in the chat for where folks can get involved with that, I would highly recommend, if you aren't already, to look that up. Just from our own experience, I want to say that the program has been really enriching. It's broadened our internal knowledge on the topic of affordability and electrification in ways that are both conceptual and we can apply to all projects, but has also brought really specific technologies and new insight and information in those technologies into our office, those being among them geothermal and heat water recovery. We also were able to do a second research project into embodied carbon that gave our firm a baseline understanding of the topic, but also a way into bringing that into our practice, in our everyday practice, and starting to make decisions about embodied carbon in our design projects. And it's also kickstarted conversations with our clients on how to bring building controls into our multifamily buildings. So apologies for the slightly long preamble, but it is a great program and I hope people will participate in it. We're presenting here today a broad overview of about a year's worth of research. We can't get into every component of it. We're going to be focusing really on geothermal and then a high-level overview of the research. But we do have free resources on our website, castrucciarchitect.com/insights, or you can go to the QR link. There's a couple of reports there. There's an embodied carbon report. There's the full deep dive, which is sort of at the top. It's like a 50 or 60 page. You can really get into the data and the nitty gritty. Or there's also sort of a 4-page tear sheet that you can get like a 10-minute overview of all the results. So I encourage folks, please download that now or later. You can follow along or dig into the details later. Okay, quickly to sort of set up this conversation, I want to very quickly talk about why we're interested in the topic. We do a lot of affordable housing in New York City. Most of it is with a specific focus on deep sustainability and passive house. We care quite a lot about these buildings. We want them to be deeply sustainable, also affordable, and most importantly, wonderful places to live. At the same time, we recognize that there are real constraints, time constraints, and specifically budget constraints that can make it hard to achieve everything we need. But I would say in general, us as an industry have really made great strides in getting passive house as a baseline into affordable housing. And that's largely been based on a business case that we've collectively been able to make. And as we go from mostly electric buildings to fully electric buildings, we acknowledge that there is a cost in operating those buildings. It's going to be a changing cost, and we want to be sure to preserve the business case for these passive house buildings, most especially in affordable housing buildings. Really quickly, broad overview. I doubt anyone here needs this. This is to say buildings, and specifically residential buildings, are a fair amount of the energy and the emissions in the United States. Zooming into New York City and really the nut of the problem that we're talking about here on the left is something we've called the utility gap penalty. And that's in New York City. Gas is significantly less expensive than electric. So while we support moving to fully electric buildings, we also have acknowledged that on a per energy unit basis, it's more expensive to do that. Now we have lots of strategies already in place for overcoming that gap. Passive house drives down the demand of heating and cooling, for example. We have heat pump technology to make more efficient than our gas appliances. But especially in things like hot water, where passive house can't get us to drive down that demand, and even the most efficient equipment can't overcome that gap. Our question coming into this was, we know that that's going to be more expensive. Is it going to be significant? Is it going to affect our client's bottom line? And if so, how do we get around that? How do we overcome that gap and drive down the cost to sort of back where our baseline was, or even better? This is most important to us. We do a lot of affordable housing, but it affects this utility gap problem affects affordable housing more than market rate, just because the utility cost is a bigger portion of the pie in affordable housing. It has to do with the fact that I think affordable has a smaller total pie, and they're also taxed a little differently. So, but that is to say, each dollar that we spend more in utilities in affordable housing building has a bigger impact on the operational budget. Okay, so that's sort of the why we're studying this. Just talk briefly about what we did, and then hand it over to Anna for a deep dive into the details. This is our case study. This is the Beacon project. It's a project that's nearing completion of construction documents. It's a 2-building project in East Harlem, New York. In the background, there's a new construction, 100% affordable residential building. It's 281 units. In the foreground is the other component of the project, which is adaptive reuse of a school, plus a one-story addition that's for community facility and community groups. For this study, we're specifically looking at the multifamily building in the back, the new construction, and we're interested in what's the cost of electrification. So the first thing we did is we created a baseline of a fully electric building at code. We compared that to how we would do business as usual, which Anna will get into, which is sort of a hybrid building. And then we identified a series of strategies that we felt would help us get over that utility gap problem, some of which we had we have a lot of experience with. We've implemented them for years and even decades, and some of which we don't have experience in, and we're really researching and establishing case studies for it. We used Woofy Passive for energy modeling. That was supplemented with eQuest to get hourly energy use rate information, which is needed for some of the building controls and time of use research that we did, and then this was supplemented with analysis and modeling from consultants from solar, geothermal, and building controls. With that, I'll turn it over to Anna to do a dive into our research.
Great. Thank you, Grayson. Thanks everyone for being here today. On the screen here, you can see the utility cost reduction strategies that we studied in comparison to this code-compliant fully electric baseline on the left. We generally group the utility cost reduction strategies in terms of envelope strategies like passive house in green, renewable energy strategies like solar and geothermal in orange, and energy control strategies like BMS and time of use rates in blue. Before we get into the utility cost reduction strategies, we really want to frame what a code compliant baseline really means. So as we get into the performance of the other strategies moving forward, and you'll see on the chart, the code compliant, even though it's fully electric building, locks us into really high utility costs, significantly higher than every single scope we're going to look at after this. In addition to really high utility costs, it locks us into really high energy loads, oversized equipment, as well as really high peak energy demands. So when we think of high energy loads and peak energy loads, it's not just a high utility cost impact, but there's also a greater impact to our energy system and our communities. High peak energy events lead to turning on peaker plants, which are essentially highly polluting fossil fuel driven energy generation plants that turn on only for the highest peak energy demands, like in the middle of the day, in the middle of the summer. This is a big issue because they spew out a high amount of emissions and carbon, but also highly toxic fumes. And these are usually located in lower income communities or communities of color. So decreasing our energy loads, decreasing our peak energy demand is critical to our utility costs and operating costs, but also it's a environmental justice imperative. So that's just pretty critical as a reference point for why we're doing this as well. The next, excuse me, one moment. The next point of comparison that we're going to be looking at is this passive house plus gas case. So this is the business as usual case that Grayson was pointing out. You can see here, that's what this dashed black horizontal line going across the screen is. And that really indicates how much a multifamily building that's mostly electrified, but still has gas domestic hot water would cost annually. This is a really salient point of comparison because even as full electrification becomes mandated in different parts of the country and the city, this is usually the industry standard. It's a way for us to get the lowest utility costs. We electrify everything we can control with passive house and other envelope strategies. And then the end uses that are dictated by resident behavior, like domestic hot water, stay with the lower cost energy source. So as we move to fully electrified domestic hot water and fully electrified buildings, we really want our buildings to operate as affordably as this comparison. So a little more wayfinding on this chart. This is the annual utility cost for all the strategies. You can see all the strategies on the x-axis, and then the total utility cost in black with the utility cost with solar overlaid in white beneath it. Next slide, please. So as we get first into how do we decrease energy loads, looking at envelope strategies, passive house, we know, tried and true, we've been implementing it. And while this does illustrate the utility gap penalty that jumped from the $295,000 to $355,000, if we look at it in comparison to the code compliant baseline, we're still seeing a significant decrease in utility cost, decrease in energy. Next slide, please. We also looked at what a high performance envelope looks like. So this is when we follow the passive house principles and we get 80 or 90% of the way there, but it can't quite be certified. And what we found is that's still a really worthy pursuit. We see only a marginal increase in utility costs, but for the beacon, this looked like a $2 million upfront savings, which is could be really critical to some project budgets. So after we look at envelope strategies, we're looking at what our focus is, what strategies can we use to complement passive house to really overcome the utility gap penalty and make better buildings. So the first renewable we looked at, here we're trying to decrease reliance on the grid, is solar. This is the most tried and true renewable we looked at. Is incredibly versatile, even for dense urban environments like New York. But more importantly, as we look at utility costs, we see is really effective in working with Passive House to overcome this utility gap penalty. Passive House plus solar overcomes utility gap penalty by about 85%, only being 4 to 5% more expensive than a gas hybrid. And we are seeing somewhere around about 42% cost savings from the code compliant baseline, which is really significant for these large buildings. Next slide, please. The next renewable that we're going to look at is geothermal. This is the one we're really going to focus on. And you can see here off the bat, it performs the best out of any of the strategies we looked at. Not only does it overcome the utility gap penalty, but it actually surpasses it, making a Passive House plus geothermal building more affordable to operate than a gas hybrid, which is really critical. We're looking at a 7% savings before solar, and when we overlay solar, that's additional savings as well. Next slide. We can see that geothermal also performs really well in terms of energy and on the top graph and carbon on the bottom graph. So in the wider report that Grayson mentioned at the beginning, we looked at all these strategies in terms of energy, carbon, and utility cost. But here you can really see that not only is it effective in decreasing the cost of the energy that we're using, but the overall loads and carbon emissions are decreased as well, which is in direct comparison to some of the strategies we'll get into later, like BMS, where they don't necessarily decrease all the energy, but it just decreases the amount that that energy costs. So as part of the purpose of doing the early design support research was understanding how do we get these strategies integrated into the building. So as part of this research, we worked with a third-party geothermal provider, in this case, Brightcore. And essentially, we worked with them to put together a feasibility analysis. So they give us an overview of what the system would be, as well as the spatial and financial cases that we'll get into in a minute. But essentially, the geothermal ground loop works that Brightcore, whoever the third-party provider is, would provide the loops that do the heat recovery, the heat exchange, and then those connect to the building HVAC, which would be designed by your typical architect MEP team. Next slide. They also provide the spatial feasibility assessment. So they look at your site, they look at the geothermal potential, and can tell you that to meet 100% of the loads that you're looking at, we're going to need 15 bores for the community facility in the front of the site and 43 bores in the back of the site. And this is helpful spatially for us to understand what's feasible. Is this going to go in before the building? Are we going to have to drill through the floor of the community facility, etc.? As we move into the financial case, this is also a key part of the feasibility for the client. And they give us the financial feasibility of the ground source heat pump in comparison to the current HVAC design. So that includes the upfront costs, capital costs of the system, and then you can also see it includes some federal incentives to decrease the cost of the ground source heat pumps and lead to savings, which you see in green on the right. And they provide this upfront cost as well as the annual operating costs. So this is for the adaptive reuse. And if we flip to the next slide, we also got it for the new construction building. I do want to note here that this does include federal incentives, this financial case. We don't know exactly what the financial grant landscape is going to be moving forward, but it's really critical to look into what incentives are in place because it can make a really big difference in making the financial feasibility of these systems plausible. Before we move on to wastewater, I just want to note that this geothermal feasibility assessment was really critical for our understanding as design professionals for the Beacon project and also for our clients. And unfortunately, by the time we got this assessment done and we understood how to integrate it into the building, we were already into design development and it was just too late for us to integrate into the Beacon. However, what the early design support program and research allowed us to do is we now have an understanding of the systems and how to get the information for each specific project. So we feel moving forward, if we were armed with this information earlier in other projects, we could have gotten it included in the beacon, and we're looking forward to doing that in the future. So the next promising renewable strategy we looked at was wastewater heat recovery. This is a strategy that we found out a little bit too late to be fully included into the report, but it shows a lot of real promise for doing heat recovery to directly cover domestic hot water loads, which is really the load driving the utility gap penalty. So this is a totally hygienic technology that works similar to an ERV for ventilation, where it takes the heat from expelled wastewater and uses it to preheat domestic hot water. And we're looking forward to trying to get this in future projects. So after we decrease our energy loads with the envelope strategies and we decrease our reliance on the grid with renewables, we decide to look at what could we do to adjust when energy is used and how much it costs. So we're looking at rate structure and BMS controls, building management system controls. So we looked at an array and combined them all in a best case scenario, but what we're finding is that in implementation, it's more going to be a specific kit of parts or bundle that is really chosen based on the project specific constraints and goals. So next slide. First, all of the controls that we looked at are used in conjunction with time of use rates. So this is an optional rate structure provided by Con Ed in New York, but exists elsewhere, that incentivizes off-peak usage by charging much less than the standard rate for energy used, in the early hours of the morning, and then charging much more for energy used at peak and super peak times. However, what we found is that you need an actual system to realize these incentives. So that's where we turn to using BMS controls in conjunction with the rate structure. Next slide. So this is a chart showing, this is a heat map showing the energy loads for every hour of every day for a full year. So you can see all the all the hours of the day from hours 1 to 24 on the x-axis at the top of the graph, and every day separated by months on the left, going from January to December. And what you can see here is that the color of the graph gets much redder in the middle of the summer, middle of the day, and much greener at these off-peak times. And what you can see here in the white diagonal lines is where these different controls target the energy controls. Next slide. So briefly, we looked at a couple of different controls. Not charted as fault diagnostics and detection, which is essentially a mechanism to make sure you're not spending money on heating the building in June, and can be really critical to realizing overrides are on. Sorry, if you could go back one more. The peak demand is a strategy that targets house loads and is mainly automated. So this is things like decreasing fan speeds and lighting, dimming lighting when there's no one in the room. Next, we looked at hot water controls. So this is the controls that are most targeted to this load driving the utility gap penalty. And so what this does, if we go to the next slide, is it preheats the water that would be used across all seasons, is based on resident behavior. And it preheats that water at off-peak times so that the energy used at on-peak times to bring the water from the preheated level to the use level is much lower. So this is a strategy that's really targeted just at domestic hot water. And then the last one we looked at was demand response. So this is more tenant load focused and has more flexible opt-in options. So these are things like temperature set point controls, as well as resident incentive apps, which connect tenants directly to the utility provider so they can realize real monetary incentives for turning down their AC or turning off their lights. And then lastly, we looked at all of these in conjunction with each other. And we see that they show real promise for overcoming the utility gap penalty and surpassing it with multiplied solar savings from the time of use rates. However, what we're finding as we look at how to implement this in the beacon is that the reality is it won't be all of these controls at once, but dependent on the project goals. Is it low investment, we're doing fault diagnostics and incentive app, or is it high impact and we're just doing domestic hot water? So in conclusion, what we learned from this is sort of a methodology would bring to future projects. So we're looking to decrease energy loads using the envelope, then decrease reliance on the energy grid using renewables, and then looking to new strategies to control when energy is used and how much it costs. So if we go to the next slide, we have a couple of considerations for these recommendations. Some of these strategies we find are really market mature, demonstrated, we know how to do it, they're incredibly effective, like passive house and solar. Other ones like geothermal are demonstrated and highly effective, completely overcome the utility gap penalty. However, they take a little bit more care for integration. This includes making sure we try to integrate it as early as possible in the project, but also addressing some client concerns around capital costs and hesitation, which we have the tools to overcome. There's a wide variety of case studies from the Buildings of Excellence program, the Empire Building Challenge program, other networks in New York, as well as most geothermal providers provide a range of ownership options, which could overcome the capital costs. And then there are technologies like wastewater heat recovery and time of use rates with building management system controls that have a lot of promise and have a range of implementation scales, but we really have limited demonstration. And so we're looking to implement them, get a better understanding of how they work, and we're looking for other design professionals to do the same and share information so we can expand our toolkit. I'm going to pass it back to Grayson. Thank you all.
Yeah, thanks, Anna. We're about wrapped up here. I just do want to underline a few points that we got into here. And the first is that there is, we do want to electrify buildings. We're all behind that, but there is, at least in New York City, there's a cost component to that, but there are ways to overcome it. And many of them we're already doing. Some of them we're a little less familiar with. And so we're hoping to see, sort of research and case studies from other folks and get knowledge share and information so we can sort of collectively get the right strategies into our buildings. And that's where something like Buildings of Excellence, I think, is something just, again, that we would encourage other folks get into that program and get into that knowledge share database. And then secondly, it's just speaking as an architect in the role of the architect. This is a great project for us. We got to speak to a lot of experts, which we love. And I'm always sort of struck that we have such intelligent consultants who know so much about their specific industry. But I really think the role of the architect is to make the connection between that specialist and the owner. Even something like solar, which almost everyone's doing, I always find there is a role for the architect to improve that solar design and the way that it's interfacing with the building. We have control over that. And then even something as simple as that the owner may not be aware of all the ways they can be financed. I've definitely seen owners try and walk away from things they should be doing because they didn't know what the financing options were. Extending that into something like geothermal, which we're less familiar with, but now armed with more information, we can, just bring that to our clients' consideration early in the project. I think we can see these get built in New York City, opening up a dialogue about what problems have been experienced in the past. We found that, a client didn't want to do geothermal. They had a problem in the past. It turned out that it was an open loop system, and that's not what's being proposed here. So it's just, there's just definitely a role for us and facilitating that dialogue. And then also in advocating for and exploring newer technologies like wastewater and time of use. So to wrap up here, there we go. I think I talked about the resources before. We gave a website link. Those are free. I hope you'll download them and use them for your information and to improve your process and design buildings. And if you have questions, please reach out at any time. The next steps for this project, as it says, we're wrapping up construction documents here shortly. We don't know the closing timing yet, schedule yet. So we don't quite know the construction schedule, but we are looking forward to seeing these passive house buildings built here in the near future. And with that, I'd like to thank everyone for their time and open it up to for questions. Thanks all.
Thanks so much, Grayson and Anna. Before we jump into questions, which we will do and have plenty of time for, we're just going to take a quick break for a thank you from our sponsors.
Yeah, thanks. Big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks too to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. Thanks too to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, and Source 2050. And thank you to our patron sponsors, Brennan, Holstrom System, Enotech Windows and Doors, Lamelux, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Thanks, sponsors, and thanks, Zach. Okay, so I think before we jump in, there was just a general question and a clarification request for some folks that might have joined a little bit late on reiterating what that utility gap penalty is between gas and electricity.
Sure. You want to take it, Anna?
Yeah, sure. So essentially, the utility gap penalty is the increase in utility costs that we're seeing when we go from a mostly electric building with a gas domestic hot water system to a fully electrified building. So in one of our previous charts, the cost of a hybrid gas building was around $295,000 a year for our case study, and it jumped up to around $355,000 a year. And the driving force behind that utility gap penalty is that, at least in New York and other regions, the cost of electricity is about 5 times more expensive than gas.
Thanks, Anna. And then there was some chatter in the chat about, you know, the cost of the actual infrastructure of the systems and how that is, you know, leading or sometimes stopping decisions from being implemented, especially on the geothermal side. Jeff, I know you were talking a little bit about calculations that you do on the single family side and how that scales differently for multifamily. I know that timing seemed to be like more of an issue here in terms of at what point you started looking at the geothermal potential in relation to how design was developing. But if you could speak a little bit to either how the cost results like change that conversation for this project, or how it's changing conversations, you know, for other projects where you're able to get in a little bit earlier for implementation.
Sure. Yeah, I mean, it's just back to why the implementation challenge here was the timing that we were coming in and sort of design development instead of at the beginning of the project. It's a relatively complex project for the team already. It's a dense urban site. It's passive house. It's got 2 components, and so there was just less of an appetite to bring on a new level of complexity over systems that had already been designed to some extent. And so it just didn't make sense for this specific project. And that said, the financials were good as long as you assume the IRA tax incentives are in place, which they currently are. But looking at other projects, I'd say the biggest implementation hurdle is just lack of familiarity. It's definitely being done in New York. It's definitely being done at buildings of this scale, but not every developer has done it yet. And so, you know, some developers may have had a project 10 years ago that didn't go so well, that was a different kind of system, or they just don't have experience with it and don't want to be the guinea pigs. And that can be difficult to overcome. And that's where I think sort of us as designers becoming more familiar with it, bringing it earlier in the phase, making that argument over and over again, taking them to the projects that do work and talking to the folks out in Brooklyn who are doing this, and they can say, here, I've been operating this building for 5 years. Here's my experience. That's the sort of the pathway to breaking down that barrier.
Thanks. And I saw Chris had his hand up. If you're still here, Spikowski. You're welcome to ask your question live. I'll give Chris another opportunity if you're still with us. Looks like you are. Okay, we'll move
All right,
on.
I think I've
there-
unmuted.
There you are.
Sorry about that. I'm wondering what role programs like Connected Solutions with National Grid, Eversource, and Unitil, where a battery is selling electricity to the grid at a rate of $6 per kilowatt hour, at least here in Massachusetts. How does that fit? Are there opportunities?
Chris, that's a question about solar batteries?
No, solar isn't needed. It's just the battery itself. Tesla Powerwall would be the common one, but there's plenty of other battery manufacturers which store, let's say, 10 kilowatts of energy. And if the utility says, hey, we're in a high demand period, instead of making your room hotter, you just, because you're turning up your AC, you're just selling 10 kilowatts of energy to the grid, and they pay you. In terms of my experience last summer, I was paid $6 per kilowatt hour on average over 420 kilowatt hour total for the summer.
Yeah, so we looked at battery storage. It didn't make it into the final study, and the reason we looked at it initially was we thought it was going to have a really good sort of knock-on effects with the time of use rates. Like, oh, well, if we're basically, we couldn't get in a lot of detail, but essentially with time of use, what we're trying to do is move our load off peak, and take advantage of a program where that's very inexpensive to do so. But if we're using energy during the peak, it's very expensive to do so. And we thought with a battery that could make a lot of sense. What we ran up against was it's hard to get that implemented in New York City. There is a pathway, but you need to essentially create a new UL listing for the battery itself at each unique. So each project would have its own sort of testing, UL testing for integration. And so what we settled on was let's think about what a future building would look like. What can we do now to facilitate in the future when it becomes easier, when the code becomes easier to get these things in, to put them into buildings? So, running the electric conduit in the short term, carving out a space physically in the project, and making sure that that space is safe and fireproof and also structurally sound. So, but unfortunately, what we don't have is sort of data about how that would interact with the system.
So you're saying it didn't pencil on time of use rates, but do you have a program there that is like Connected Solutions? It's in Rhode Island. It's they average out the kilowatt hours, but the multiplier they apply is like $275 per kilowatt hour. You don't get that because you're getting average, but do you have a program that's going to help it pencil?
I'm not sure. Maybe somebody else in the chat can answer that. That there may be in New York State. I would suspect there is. But just getting back to the sort of regulatory environment in New York City, it would be difficult to get it. I think that's a short-term problem, though. I think that's not going to be forever. But to answer your question, I'm not sure specifically. I would suspect there is, and I bet if we monitor the chat, somebody will drop something in.
Thank you.
And speaking of which, Kevin M had a question about the utility rates. Grayson, I'm not sure if you can pull back up the slide where it compares electricity to gas. And, understanding that's a more maybe regional specific issue. But that would be good to look at again, as it, I think, also clarifies that utility gap penalty as well. And I had a question from the controls reduction side of the study. You mentioned using incentive apps where you give more control to users to incentivize them to reduce. Curious, what apps specifically you looked at and how you quantified their impact to get actual numbers for the results.
Sure. I can start, and Grayson, feel free to hop with additional information. So I think the main resident incentive app that we are looking at was Meltech, and essentially the way it works is it's incredibly low capital costs for the development team, and basically onboarding residents that to download this app that would get alerts straight from the utility company that to turn off their AC, to turn off their lights, and turn down the set points, and then they directly get real monetary like rewards for doing that. And so the capital cost for that is essentially onboarding tenant orientation that this is an option and they should do it. I think there are a range of other apps that we looked at. Meltech isn't the only one. But in terms of quantifying it, we did work with Ecogy. I believe they've changed their name potentially to Sentient. Grayson, hop in if I'm messing that up.
You got it. That's right.
Okay. Essentially, we worked with them, and since they do building controls, they use their own proprietary tools to give us an understanding of what the savings are going to be. So that's a little bit of a black box for us. But I believe the resident incentive apps are sort of combined with other demand response options that they provide.
Cool. And that makes sense, getting it directly from a controls expert. So we have another question for Grayson. Aaron Yasin, do you want to come on and ask your question?
Sure. Terrific presentation. Really appreciate the time and effort to put it together. I have a question just in terms of application for some of this research. I'm focus on market rate development projects at the moment, primarily condominium development projects in New York City. I'm focused in Brooklyn at the moment. And I'd love to incorporate as many of these strategies as possible, but for the most part, I can't figure out how to incorporate nearly any of them. And I mean, I just have this example. There's this looming project not far from where I'm working that's a full passive house, and it's been on the market for 12 months. It looks like a total disaster financially, unfortunately, for whoever the sponsors are. If I'm working on a new project, really, I would need to condense all of this work that you've done into 2 to 3 months to be able to implement any of it in the design phase, the early design phase. How can, and then also there's other implications and questions that I have, like if I've got a project site that has any MTA implications, how do you do geothermal? It's probably not possible, right? Maybe that streamline the timeline because you can't even do it, so it's off the table. But how can I think about this process that you've gone through here in an efficient way to actually be able to have some level of success, knowing that we're not going to be able to get to this. We don't have the kind of time that you've put into it for this project.
Yeah. That's a great question. So I think that to start, the key is having really good consultants. You don't want to, if you're doing passive house, don't maybe hiring someone who has experience with it, so they're not, we weren't researching passive house as part of this. It's sort of just what we do. It's going to be in the same timeline as all the other work. Another thing, just getting to sort of your bottom line, is if you're building, are you doing new construction or rehab?
New construction, ground up.
Yeah, I mean,
yeah,
you should definitely be taking advantage of the 5% zoning bonus that you get for energy efficiency. And if you're going to do that, you might as well, if you're going to claim that benefit, which means you're putting more insulation and better windows, you might as well do it in a way that is holistic and you're actually getting the benefits energy wise. And then take that 5% and put it on top of your building or make your building a little bit bigger. Solar, again, I don't think there's any schedule. There's no, start talking about at the beginning, design your building so that there's roof space to put solar on. It shouldn't affect your bottom line schedule. And then things like geothermal is not going to, as you said, it's not going to work for every site. I don't know how big you're talking about. I mean, if you're talking about 3 families,
Yeah, no, that's impossible.
Yeah, it may not work, but I mean, on a bigger timeline, I think you can, a bigger project with a larger timeline, you can probably get, you have a big foundation, you can be drilling wells while you're working your way around the foundation. I think though, you're probably, unless you're doing this mission driven, you're probably not doing the new stuff that we're researching for the first time in this project. You want to do some of the more mature stuff, but there are people who are doing, who are going to do the wastewater heat stuff in a project, and by the third one, we'll have 3 sets of data that you say, okay, now I'm comfortable, I'll put this in, this makes sense. And then from a development perspective in Passive House, I would say it's at least agnostic. I don't think it's going to shouldn't be driving anyone away. We did a development project. It's been a few years, but we did an in-house development project. It helped sell it. This was like in 2016. We got slightly more than market around the area. Certainly recovered the investment. And at this point, there's no schedule impact, maybe a small 1 or 2% construction cost impact. But again, if you're leaning back and getting things like a zoning bonus for it, then I think it's worth the cost.
So it sounds like just sort of high level that if geothermal is possible, that's a really good one to look at early on to determine if it's, because the impact is significant and it can be, the cost can be balanced with other types of systems that would be utilized.
Yeah, and I think geothermal is mature. I think geothermal is a thing you can do. You just got to have a little bit bigger site, and the right site, obviously not over the subway. And
Right.
and the more campus space you have, the better. It'd be nice if you had a little bit of space in your yards. It's not necessarily needed with the drilling technology, but it's certainly better. But yeah, I don't. Outside of geothermal, I don't see any reason why you couldn't be doing passive. If you're not certifying Passive House, doing the principles, and certainly solar. Every project in New York City can fit that in their budget and timeline. We're doing it on affordable housing. There's no smaller budget, so we're making it work.
Right.
I would also add to the part of the question that's about how do we integrate this early. Like that's a really critical part. Is a lot of these elements, there's ways to get feasibility done super early. As Grayson said, if you work with firms, architecture firms, sustainability firms that do Passive House, like there's such a wealth of knowledge in the New York area and people that know how to do this. But outside of just Passive House, you can get really preliminary solar feasibility. I believe it's mostly free early phase solar consulting. Any of the bright geothermal providers would be happy to do an early feasibility study because they want to get it in the project too. So I think that was a big takeaway, that if you want in the project, talk to the providers, you can get an early feasibility analysis. Doing the actual implementation obviously takes care, but there's ways to get the information early.
Yeah.
Great.
I don't know if we mentioned this, but like we did not do geothermal on this project. We are not super experienced with it. So as far as total timeline, I don't know that geothermal specifically we'd be the one to ask, but we know the people to ask. And then Aaron, sorry, this is a little bit of a field, but just looking at your question, you can look at modular too. That's something that we've done a little bit of, and that's a way, and you can do that Passive House.
Definitely looking at it.
The site has to be right. The typology, market rate of residential is a good typology for it, or can be. You got to find the right site, but it's being done. There's a couple of them being done in the city. It's just finishing up now. We did one of them. It's definitely feasible and potential.
Where was the project that you did with modular? Was it in the boroughs or in Manhattan?
Flatbush in Brooklyn.
Okay, yeah, that's a little more accessible. Who was the modular manufacturer? Can I ask?
Whitley, Whitley, and then there's a bunch. Can't remember off the top of my head, but if you drop your email or if you private email in the chat,
were those not just panel sections? They were larger and
full boxes. Yep.
Right. So you were able to get all the DOT stuff and move them into the location. That's why obviously Manhattan's more challenging.
Yep, that's right. The other project I'm aware of was in a denser part of Brooklyn, and I forget exactly the cross streets, but yeah. But they were both 3-dimensional geometric mods, you know, so you build a 6-sided box with an apartment fully
Right.
furnished on the inside, you deliver it on a truck, you stack it up.
Right, right. Yeah, so your build time really was reduced on site
Yeah.
dramatically. Okay. Terrific. Thank you very much. Really appreciate it. Very helpful.
Yeah, great. Thanks for the question.
Yeah, thanks. That was a great question and great little follow-up conversation. I also just wanted to shout out NYSERDA in the scheme of like, you know, how do we get this information out so that not every project has to do maybe as in-depth of a study, or they don't have the time to study every technology, but they want to understand like, you know, scale of magnitude. Is this on the table at all at a high level for the project? And that's kind of the point of these early design support projects through NYSERDA, is that Grayson and Anna and other teams are doing so much good work that does take a long time and might not even be, you know, at the end of the day implemented on the project that they research, but then it goes out to the public and it's a resource that's available to look at. And, you know, it might not be, the cost figures might not be specific to your building, but the magnitude of them, you know, can be applied. So that's another way to think about this, is like pulling from, you know, other projects and research to do high level of like, all right, what do we want at the table, and then what do we need to pick out to integrate super early, because it is on the table from, you know, from like from that kind of comparison, very high level view. Awesome. Well, I think we had one more question come in around how do you gain passive house education in NYC, meaning which schools? I think any one of us could take this, but if Anna or Grayson, you want to take that?
You mean like what are the, no, go ahead, you please take it. I'm not the best suited for this. Yeah.
Yeah, so getting a broad passive house education isn't specific to a school necessarily in terms of, you know, higher ed. There's education available through the passive house certification agencies, so through PHI, Passive House International, Passive House Institute, the international standard, or FIAS, the US standard. But in New York State, there are a lot of schools, university level schools, that have integrated the passive house, specifically the FIAS CPHC curriculum, into their coursework. And so they have courses as well as the City College, CCNY in New York City, has integrated passive house courses. So I hope that answered your question, Jess. If not, feel free to connect offline. I'm going to close out with a last question to Grayson and Anna that I like to hear from practitioners, and that is, what do you see as what's up next? Like, what is the next kind of cutting edge, you know, thing in your work and that you're excited about?
You want to go first, Anna?
Sure. I think one of the most promising new technologies that we got information on is wastewater heat recovery, both at a building scale, but looking at how it can be done on a campus-wide scale, larger scale. I think there's a ton of promise for how we can use like the same technology we've been using for a long time with ERVs for domestic hot water. So we're hoping to get that in a project soon. And then other than that, you know, looking for how we can integrate these other high performance heat recovery, high efficiency electric heating and cooling in our retrofits. So that's sort of what we're focusing on, or for me personally, I'm very excited about getting integrated.
Yeah, and then I have a laundry list. I'll highlight a few things. I mean, we've got a lot of stuff we're interested in, and again, with early design support, one thing that's cool is there are other people in the cohort and you learn from them. So there was some really cool like life cycle analysis modeling that was done by some of the other cohorts. So that's something we're really interested in. Some of the embodied carbon, the modular we talked about, and like how do we prefabricate, how do we build differently so it's more efficient, faster, and better. And then adaptive reuse is not a new idea, but like really pushing into that and exploring that frontier. So those are just a couple of things that are top of mind for me.
Awesome. Thank you both again so much for sharing your insights and for all the hard work in putting out this like open source, publicly available data that everyone's going to benefit so much from. Just a quick reminder that next week's session is Passive House 101 airtightness with Kevin Brennan. So if you can join us back next Wednesday, that'll be kicking off the airtightness month. And thanks so much. I hope you all have a great morning, afternoon, night, wherever you are. We'll see you soon.